So identify the rational expression that's equivalent. So equivalent means you can multiply the top and the bottom by the same thing, or you can divide the top and the bottom by the same thing, right? So if I multiply this one here, you'd have to divide by 4. If I divide this, it would be these ones by 4 as well. So it's not going to work. This one I have to add an x to, so then I have to add an x to everything. So 4 times x is 4x squared. Yeah. X times x is x squared. No. This one, they divided by 2. So 4x divided by 2 is 2x. X divided by 2 is 0.5x. And then 5 divided by 2 is 2.5. So it's C. 1 mark. Determine the non-permissible values. Looks a lot like the one from yesterday. If you have a number in the bottom, no variable, then you have no restrictions because the bottom can never be 0. It's 6. Which of the following rational expressions, which rational expression is simplified? So this one here, I can take an x and a 2 out of them. So I can divide by 2 and x. If I can divide by anything, it's not simplified. This one I can't take out anything, so it is simplified. This one I can divide by 5. So it's not. So it's just 2. Determine the non-permissible value. So I have 2x plus 12. 2x plus 12 can't equal 0. 2x can't equal negative 12. Divide by 2. And x can't equal negative 6. See? And then 5. What can you take out of 42 and 72? 6. So I take a 6 out of 42 and I'm left with 7. A 6 out of negative, can you take a 6 out of negative 72? 12? Yeah, because 5 times 12 is 60. I said that earlier. That was what we were asking. Okay, and then d squared, take out 2 of them. And so you're left with 7 over negative 12d. And d can't equal 0 because we have a d by itself on the bottom. And we will say MPVs before we cancel, right? So it is D. Put a mark out of 5. Okay, so we've done equivalent rationals. We've done NPVs, non-permissible values, and we have done simplifying rationals, right? Today we're going to look over multiplying and possibly dividing. So multiplying rationals follows the same rules as multiplying fractions. So what you can do is you can cross off anything that's common on the top with anything that's common on the bottom before you multiply. So I can take a 5 out of the bottom here and a 5 out of the numerator, the top here. So 5 divided by 5 is 1. 5 divided by 10 is 2. So as long as it's on the top anywhere, I can take it off the bottom anywhere. So they can be on top of each other and the bottom, or they can be across from each other. That's fine. It just has to be on the top and the bottom that they can cancel. Then with 21 and 3, I can take a 3 out. 21 divided by 3 is 7. 3 divided by 3 is 1. And then once I've simplified it as much as I can, top and bottom, I just multiply across the top and across the bottom what's left over. So 1 times 2 is 2. 1 times 7 is 7. Done. So with rationals, it's a little more complex because you have variables and you have more stuff to do to it. So the very first thing you do when multiplying rationals is the very first thing you do when you're doing simplifying of rationals. Same step. GCF, wherever possible, and difference of squares. Once we've GCF'd and difference of squared, all the tops and all the bottoms separately, so all the numerators and all the denominators, then we have to state non-permissible values. Non-permissible values are for any denominator, right? Anything that's in the denominator can't equal 0. If it equals 0, we have a problem. So we're going to state NPVs for anything in the denominator, not just one side, but any side. Then we'll reduce like we did up top. Anything that's common on the top can cross off anything that's common on the bottom. And then we just go across the top, write what's left over, go across the bottom, write what's left over, just like we did. So the very first thing we want to do is GCF difference of squares. So the top left, the numerator on the left, what can I take out of it? What GCF can I take out? The top left, Cody, a 2x. So if I take out a 2 and an x, out of 2x squared, I'm left with x. 12x divided by 2x, I'm left with minus 6. And then that 2 and x, because they're multiplied, can be in their own brackets, remember? The bottom I have a 15x. Can I do anything to that? No, the only thing I can do is put the 15 and the x in their own brackets, but that's about it. Little symbol, the dot symbol, the times. They often use the dot symbol instead of a time symbol just because the time symbol looks like an x, right? So they usually use the enclosed dot for multiplication. On the top left, or sorry, top right, the numerator on the right, it's 5 and x. Okay, and then x minus 6 in its own brackets. So before we cancel, because remember I said when you see something that matches on the top and the bottom, you get super excited because they match? Yeah? Before you do that, you need to state NPVs. All right. So 15 can't be an NPV because it's 15. When x is by itself, x can't equal 0. And then x minus 6 can't equal 0. So x can't equal 6. So x can't equal 0 or 6. Is our NPV. Now, Bree, what cancels? X minus 6, she's like super keen. And x, and I don't like that x. So I'm doing this one. And then 15 and 5? You get 1 and 3. No, you could have just left it. It would have been fine. Rebel. Go against the machine. Okay. 2 and x, 2x. And then on the bottom you'd have 3. And do B. Try it out. Okay, so for this one, 12x cubed, they're all just multiplied together, so you can just write 12 by itself and x cubed by itself. Alexis, the bottom left, the numerator on the left, what can I take out? No, bottom. Yeah, 3. 3 and an x. And then you're left with x plus 2 times Brittany, top right. So the top numerator, what can I take out? One on the right-hand side. What can I take out? Bigger. Yeah. 4 and x squared. And you're left with x plus 2 over 5. What do we have to do next, Joe? Before we cancel. NPVs, yeah. So 3 doesn't get us an NPV, 5 doesn't get us an NPV, x can't equal 0 is going to be our other one, and then x plus 2 can't equal 0. So x can't equal negative 2. So we have x can't equal 0 or negative 2. Now, Mason, what can I cancel? X plus 2. One of the x's. It doesn't matter which one, right? And we'll knock this one down to a 2. And what else? Yes, you can take 3 out of 12 and 3. So 3 divided by 3 cancels. 12 divided by 3 is 4. And then I think that's as good as it gets. So then we get 4 times 4, which you can put together first, is 16. X squared times x squared. Whenever you have two bases that are the same, you add your exponents, right? In this case, you would have lucked out if you multiplied anyways, because it still gave you 4. But you add your exponents. So it's like I have an x and an x and an x and an x. So I actually have 4 x's over 5. Okay, so we only did NPVs of what's in the bottom. So we have n plus 5 can't equal 0. So n can't equal negative 5. And then we have 2 minus n can't equal 0. And I could just move the n over by adding it if I want to. Or you can move the 2 and then divide by 1. Negative 1, same thing. 2 can't equal n. So it's negative 5 and 2, which is B. You try example 3 and 4. All right, the top one, 3n minus 1, the numerator on the left would say 3n minus 1. N plus 5 stays n plus 5. Times 2 times n in its own brackets over, I can take a 3 out, 2 out, and I'm left with 3n minus 1. So my non-permissible values are going to be n can't equal negative 5 and 1/3 when you solve them out. The 3n minus 1's cancel and the 2's cancel, and I'm left with n over n plus 5. So D. Example 4 says determine all the non-permissible values. So you'd have 2a plus 3 can't equal 0. And then the 8 and the a are in their own brackets. So a can't equal 0 and 8 can't. So I don't have to worry about the 8. This would be 2a can't equal negative 3 when you subtract it over. Divide by 2. And a can't equal negative 3 over 2. So negative 3 over 2 and 0. So C. Try these two. Okay. So this top one, 3a in separate brackets. 2a plus 5, you can't take anything out, times a plus 6 over 9 times a. So we know a can't equal 0 or negative 5 over 2 when you solve out 2a plus 5. A, 3 out of the 3 and the 9. And so I'm left with a plus 6 over 3, 2a plus 5. And if you distribute that 3 back in, you'd get a. You get 6a plus 15. This one, brackets around the separate thing. You see your NPVs. 6 can't be 0, 2 can't be 0, p can't be 0, and 1 plus p can't equal 0. So p can't equal negative 1. So it's going to be 0 and negative 1, which is all the answers, so that didn't narrow it down at all. And then we have p plus 4 and 1 plus p. There's nothing that's like with them. This p cancels off one of these p's. 3 out of here becomes 1. 3 out of the 6 becomes a 2. So I'm left with p times p plus 4 over 2 times 2 on the bottom. 2 times 2, so 4, 1 plus p. Which is a nice answer, but none of them have brackets, right? So they must have distributed it back in. So you get p squared plus 4p over 4 plus 4p. And then this is your assignment.